Hi everyone, this is Mrs. Venti. Today we are going to look at prime factors, highest common factor and lowest common multiple. This is a grade 9 video. I am using the Mind Action Series textbook. I am on page 12. I'm going to do exercise 2. Now the first thing that we're going to look at are prime numbers. Before we can work with prime numbers, we need to know what a prime number is. So on the table on the screen, and also the one that we did in class, we have got a number chart from 1 to 100. All of the purple numbers on this table are prime numbers. What do we know about a prime number? A prime number is a number that has exactly two factors. Those factors are 1 and itself. So if I take the let's start with 2. If I factorize 2, to get to 2, I will say 2 times 1. That is the only multiplication sum that gives me 2. In the same way, the only way to get 3 would be 3 times 1, or 1 times 3. The only way for me to get 37 is to say 37 times 1. There is no other multiplication sum that allows me to get 37, or any of these purple numbers. These purple numbers are our prime numbers. This is a list of numbers that you need to keep on your side and use as a reference bank. So that means that when we are busy with our this entire video or this section in math, you can look at that list and say, okay, is this number a prime number, and base it off of that. So let's start with our first question. The first question asks us to factorize the number 24 and the number 504. So there are a lot of different methods of doing this. You know that I prefer to do the ladder method. So in the ladder method, I am going to half it. Because I have an even number, I'm going to say it is divisible by 2. And based on this, 2 is definitely a prime number. So I'm going to say 24 divided by 2 gives me 12. 12 is an even number. I can half it. I can divide by 2. So half of 12 is 6. 6 is even. I can divide by 2. Half of 6 is 3. 3 is odd, which means I cannot divide by 2. If I go back to my list, 2 I can't use, 3 I can use. 3 does divide by 3. So I'm going to say divide by 3. That gives me 1, and that is where I stop. Now I'm going to move on to the number 504. 4 is an even number, so I am going to divide by 2. 500 divided by 2 is 250. 2 divided by 2, 4 divided by 2 is 2. So I have got 252. I again have an even number, so I can half it again. 252 divided by 2 is going to give me 126. Again, an even number, I can divide by 2. That gives me 63. Now, here is an interesting rule when it comes to division rules. Remember, the way that we check if something is divisible by 2, it has to end in an even number, right? So the end must be even, and then it is divisible by 2. To decide if a number can be divided by 3, so if a number can be divided by 3, how do we decide? If you take all the numbers together and you add them up. So if I take, I'm looking at 63. If I say 6 plus 3 equals 9. 9 can divide by 3. That gives me 3 as an answer. This means that 63 can divide by 3. So the rule is, if I add the digits up and they are divisible by 3, then the whole number is divisible by 3. So now I can say, okay, 63 divided by 3. 60 divided by 3 is 20, and 3 divided by 3 is 1. So I'm going to get 21. Can I divide 21 by 3? 2 plus 1 is 3. So yes, 21 divided by 3 is going to be 7. Now, 7 is not divisible by 3, but if I go back to my chart, I can see that 7 is actually a prime number. So I can then divide by 7. So divide by 7. And I am done. So if I was to write the numbers as prime factors, I would say that 24 is equal to 2 times 2 times 2 times 3. But that is very repetitive. So instead of writing them out like that, I'm going to say 24 is equal to 2, 1, 2, 3. 2 to the power of 3 multiplied by 3. And that is the prime factorization for the number 24. Let's do 504. 504 is equal to 2 times 2 times 2 times 3 times 3 times 7. Again, too much repetition. So I'm going to say 504 is equal to, I've got 1, 2, 3 2's. So that's going to be 2 to the power of 3. I've got 1, 2, 3's. That's 3 to the power of 2. And I've got 1, 7. Those are the factors of 504. So this was question A. The second part of this question is asking you, what is a factor of 24 and 504? Now, a factor would be a number that is divisible in both numbers. So if I looked at this and I said 2 goes into 24 and 2 goes into 504, therefore 2 is a factor. I could say 2 times 2, which is 4. Those two give me 4. 2 times 2 is 4. So 4 is a factor of both. So just so that you understand that a factor refers to these numbers that you can divide it by. Let's repeat the process. So we are going to do the prime factorization of 72 and 180. 72 is an even number, so I am going to half it, divided by 2. So that's going to give me 36. I'm going to half that, and I'm going to say 18. I'm going to half that, and that is going to give me 9. I cannot half 9 because 9 is a odd number. 9 is also not a prime number. So I am going to go from 2. I'm going to go to the next one, which is 3. So does 3 go into 9? Yes, I can divide by 9. So 3 goes into 9 divided by 3 is 3. And 3 divided by 3 gives me 1. Once I have 1, that is where I stop. Let's do 180. Because it ends in a 0, it is even. So I can say 180 divided by 2 gives me 90. 90 divided by 2 gives me 45. Now here we've got another instance. Because 5 is not even, I can't half it. 3 could go in there because 5 plus 4 is 9. So I could do 3. But what I notice is that this number ends in a 5. So if a number ends in 5 or 0, you can divide by 5. So I'm going to go straight and I'm going to divide this by 5. So once I say 45 divided by 5 is equal to 45 divided by 5 is 9. And now I'm going to go 3, 3, 3, 1. So I can now write these numbers out as products of their prime numbers. 72 is going to be equal to, I've got 3 2's, 2 to the power of 3. Then I've got 3 3's, 3 to the power of 2, 2 3's. So 72 is 2 cubed times 3 squared. 180 is going to be equal to 1 2 2's, 2 squared. I've got 1 2 3's, 3 squared, and I've got 1 5. Next, I am going to look at highest common factor. The first step that I do in highest common factor is going to be to factorize, and I'm going to do prime factorization. So I'm going to say 16 divided by 2 gives me 8. 8 divided by 2 gives me 4. 4 divided by 2 gives me 2. 2 divided by 2 gives me 1. I'm done. For 12, I'm going to say 12 divided by 2 gives me 6. 6 divided by 2 gives me 3. 3 divided by 3 gives me 1. I'm done. So the factors of 16 are 2 times 2 times 2 times 2, which is 2 to the power of 4. And the prime factors of 12 is going to be 2 times 2 times 3, which is going to be 2 to the power of 2 times 3. Now, this does not answer my question because what I'm looking for is the highest common factor. Once I've got my ladder going, I am going to look for common factors. So I'm going to circle them in color. So I'm going to say my highest common factor is equal to, I've got a 2 there and I've got a 2 there. If both of them has it, I write it down. Okay? Now I'm going to look again. I've got a 2 there and I've got a 2 there. Both of them has it. I write it down. I've got a 2 on the 16 and a 3 on the 12, a 2 on the 16 and a 3 on the 12. So there are no more numbers on the right hand side that both of them have. Remember, the common in the highest common factor, it means that everybody must have it. So everybody has an orange 2 and everybody has a pink 2. So my highest common factor is going to be 2 times 2, which equals to 4. Okay, so let's do the same thing. Highest common factor on 675 and 1125. So if I am going to use my pattern, normally I start with 2, but because it is not a prime number, it's not an even number, I cannot do 2. I'm not going to do 3, I'm going to do 5, and the reason why I'm going to do 5 is because I can see the 5 at the end and the 5 at the end. So I'm going to start by dividing by 5. So you can use your calculator to do this. I just did this quickly off screen so that I don't waste your time. And I'm going to say 675 divided by 5, divide by 5, divide by 3, divide by 3, divide by 3. Okay, so those are the factors of 675 and 1125. But the question is asking me, what is the highest common factor? In order for me to get the highest common factor, I need to find what is in common. So both of them has this green 5. I'm going to write it down. Then I look at the next number. Both of them has the blue 5. So I'm going to write that down as well. And then I look, is there another number they have in common? Yes, both of them has a red 3. So I write that down. Is there another number that they have in common? Yes, both of them has the yellow 3. What is left? This 3 and this 5 are left, and they are not the same, so they are not in common. So in order for me to get the highest common factor, I'm going to say 5 times 5 times 3 times 3, and you use your calculator for this, and we know our highest common factor is going to be 225. Let's do one more highest common factor question. We're going to look at 3 terms. We're going to look at 36, 45, and 162. So we follow the same process. You're going to use the numbers on your number chart, starting with 2 and move to 3, 5, 7, right? So I'm going to do that quickly. Half of 36 is going to be 18. Half of 18 is 9. And you can go ahead and do this on your own. So these are the factors of these numbers, and what I did was I did prime factorization. So my next step is going to be to look for common factors. Now if I look at 36, I've got 2's and I've got 3's. If I look at 45's, I've got 5 and 3's. If I look at 162, I've got 2 and 3's. So 2 is here and here, but I don't have any 2's here. So 2 is not common. I've got a 3 here, I've got a 3 here, I've got a 3 here. So my first number is going to be a 3. Then my second one, I've got a 3 here, got a 3 here, I've got a 3 here. So my second number is going to be a 3. So my highest common factor, these don't count. And since I'm done with this number, I'm done with everything, right? So because if it's not in here, then it doesn't count. So 3 times 3 equals 9. My highest common factor is 9. The next concept we're looking at is lowest common multiple. So what we're going to do again is we're going to start with prime factorization. And I'm going to say prime factors of 9 are divide by 3, divide by 3. Prime factors of 6 is going to be divide by 2, divide by 3. Okay, so now that I have that down, my next step is going to be, how do I get my prime factors? I'm going to show you my lowest common multiple. I'm going to show you two different ways of doing this, and then I need you to understand both. So the way I showed you in class was to say that 9, which is this number, is going to be multiplied by 3 times 3. Then I'm going to say 6, which is this number, is multiplied by, as you can see, the number 2 times 3. And the important thing for you to notice here is that these numbers are all in the same column. So my 2's go together, and my 3's go together, and my 3's go together. They have to be in the same column. So now I bring it down. I say this first column is a row of 2's. The second column is a row of 3's. And the third column is a row of 3's. So if I multiply that out, this is going to be my lowest common multiple. In other words, it is going to be 2 times 3 times 3, which is 18. My lowest common multiple is 18. Another way of looking at this is to say, what is the highest exponent of the factor that I have? So if I write out my prime factorization like this, then I am going to say 9 is equal to 3 squared, which is 3 times 3. And I'm going to say 6 is equal to 2 times 3. So I know that I've got 2's. My highest common factor, my highest exponent for 2 is going to be 2 to the power of 1. Now I've got 3's. I've got 2 3's here, and I've got 1 3 here. So I'm going to take the bigger one. I'm going to say 2 times 3 to the power of 2. And that gives me the same answer of 18. Let's do LCM for 8 and 14. The factors for 8 is going to be divide by 2 gives me 4, divide by 2 gives me 2, divide by 2 gives me 1. Divide by 2 gives me 7, divide by 7 gives me 1. So in essence, what am I saying? The factors of 8 are going to be 2, 2 times 2 times 2. 1, 2, 3, right? And then the factors of 14 is going to be 2 times 7. Now, before we continue, why do I write the 7 at the back here? Because all of these numbers need to have the same digit inside. So these 3 are all 2's inside, and the 7 must have its own column. So in the first one, I've got 2's. In the second one, I've got 2's. In the third one, I've got 2's. And in the fourth one, I've got 7's. My lowest common multiple is going to be 2 times 2 times 2 times 7. And that is going to give me 56. So looking at the other method, if I write out my exponents, I'm going to take the highest exponent for 2 and the highest exponent for 7. 2 to the power of 3 and 7 to the power of 1 gives me 57. These are the factors for 21, 153, and 119. So 21 is technically equal to 3 times 7. 153 is equal to 3 times 3 times 17. 119 is equal to 7 times 17. Again, pay attention to how everything is spaced out. So in this column, I have got 3's. In this one, I've got 7's. In this one, I've got 3s. And in this one, I've got 17s. So my LCM is going to be equal to 3 times 3 times 7 times 17. In mathematics, it's good practice to write from the smallest number to the biggest number. So the order in which we write needs to be in that order. If you don't, you won't be penalized, but it is only good practice. So now, the lowest common multiple, when I multiply them all out, is going to give me 1071. That is the lowest common multiple. Just a quick explanation. When we're talking about lowest common multiple, I'm going back to the question we did where we factorized 9 and 3. And we said the LCM was 18. What does this number actually mean? It means if I count in 9s, I can say 9, 18, 27, 36, etc. And if I count in 6s, I can say 6, 12, 18, 24, etc. The lowest means closest to 0, the closest one to 0. Common means found in both. And multiples are these answers. When I say 1 times 9 is 9, 2 times 9 is 18. So the answer of your multiple tables. So the lowest common multiple is 18, and I can see it when I list it out, and I can say, okay, I've got 18 here, I've got 18 here and 18 there. So the smallest number that they both have when you count in the multiples is going to be your lowest common multiple. Now, I sincerely hope that you understood. If you have any questions, please ask me. I wish you all the best. Please like and subscribe so that and make sure you turn the bell on so that you get notifications of future videos. Thank you. Bye-bye.